All right, welcome to global modeling. So now we're going to talk about how do we create a model for a data set that we've been given. And so we're going to do polynomial modeling for global modeling. So this first, so just kind of jumping into it, there are like 5 steps that we have to follow when we're dealing with global modeling. So the first one is normalize. The second one is set up your matrices. Then you calculate your coefficients. And then you have to denormalize after, calculate through and then denormalize to find out your new Z values on the actual model. So let's write those out. First one is normalize. The second one is set up matrices. Your third one is to calculate coefficients. I didn't spell that right at all. Coefficients. The fourth step is to, once you've calculated that, to calculate normalized heights. Then the last step is to denormalize heights. Once you've done that, then after these 5 steps are done, then at that point you can calculate your R² value and then calculate your, you're going to calculate your Fstat. That's statistic. So these are the steps. I'm going to show you all of them in this example. I'm going to be pulling from Excel as well, just so that you can see the matrices, because I'm not going to write out every single element as we go, but just to give you an idea. And I'm going to try to compare first and second order as we go as well, just so you can see the differences, especially in the A matrix, because that's really where the biggest difference is. So looking at these values, we have our X and Y and Z. So now we want to calculate the normalized values. So this is the number 1. We have to normalize all of them. So to normalize, using the formula, we have our, for example, xn, which is equal to the x value, whatever value it is, minus x min, divide by our x max minus x min. So that's the formula. You can do that for every single one of these values. And then we are going to paste this into here. And here are my normalized values for all of that. So you can see that the values are all between 0 and 1. My lowest value always shows up as 0. My highest value shows up as 1. So these all match all of these values up here. It's just these calculated through. So once I've done the normalizing, now I need to set up my matrices. So the matrix setup is probably one of those sections that people get really concerned about, but it's really not that hard. So first of all, my L matrix is actually my L normalized matrix, which is all my Z values. So this is going to be 1, 0.516, 0.964, all the way down to 0.314. Now do not round like I am. And I'm going to highlight that in red. So don't round like I am in this case, because I'm just showing you guys this as an example. You need to maintain as many decimal places as you can. You are actually going to find that you're going to have slightly different numbers depending on the platform that you use, because it all comes down to how many decimals it holds. So for example, the HP 50, if you were using that to do the calculations, or even the HP prime, you're going to find that it keeps about 15 or 12 decimal places. And then Excel holds, I think, 15 decimal or 9 decimal places, something like that. 2, 3, 4, 5, 6, 7, 8. So this one shows 9. It may hold a few more, like 12, up to 12, but that's how many it holds. If you go into MATLAB, it holds 15 decimal places. So you're going to have slightly different numbers slightly different values in your coefficients in the end, but it'll only be to a few really small decimal places, so it won't make that much of an impact. So this is my L matrix, so don't round like I am, but there's my Z normalized values. Then let's say I'm going to do my X matrix, and these are my coefficients. So if it's a first order, it's just A0, A1, and A2, right? So that is my first order. This is for first. If I'm doing a second order, it's going to have more. It's going to have A0, A1, A2, A3, A4, and A5. And that's going to be the coefficients that it has. Now my A matrix is going to vary definitely between the two orders. So my first order for my A matrix, it's going to be 1s all the way down to 15. So over here we have 15 values, here we have 15 values. So you're going to have 15, and you're going to have that many 1s in your first column. In my second column, and this is kind of lining up with A0, because our formula for first order is my Z equals A0 plus A1X plus A2Y, right? So I take the derivative with respect to A0, I'm getting 1s all the way down that column. I'm going to take the derivative with respect to A1, and then I'm going to get my X's all the way down. These are all my X normalized values. So if that's X1, then my next one is 0.04. Then my next one is 0.389, ... all the way down to the 0 value, which is on the bottom here, right? So that's what I'm doing. And then my next one, taking this with respect to A2, the derivative, I get my yn value, so that would be this one. Then my second one is going to be 0.773. My third one is 0.716, ... all the way down to 0.557. Again, do not round. So that is my first order A matrix. That's what it looks like with 15 rows. And there's going to be 3 columns. Now, what if I had my second order? So the second order looks like this: A0, A1X plus A2Y plus A3X squared plus A4XY plus A5Y squared. So this means that I'm going to have 6 columns in my A matrix. So I'm going to do this one in, let's say, purple. So my second order, it's all going to be the same for those first 3 columns. Nothing changes, it's the exact same. The next thing though is I have to do A3. So that means that now I'm going to take my X squared value, and this is in, right? So I'm going to square my X value, and that's going to give me whatever that value is all the way down. And then my A4, which is my 5th column, it's X, Y, both of those are normalized all the way down, and A5, which is my Y squared, all the way down. So you can see that we just keep adding on those extra sections. If I asked for a third order, you would add in those extra columns as well. So that is setting up. So we've done the normalizing, we've done the setup of the matrices. Now we're going to calculate through to get the coefficients. So we know that L equals AX, right? So that is the key formula to be able to figure out what a model is. And then of course we have error, but we deal with that later. So we've got everything normalized. So now we need to isolate for X, because this is what we're trying to calculate, is this one. So when we calculate this through, we end up with ATA -1 times ATL. Some of you guys have seen it like this, and that's fine too. You can use that if you find it easier to work with. So first order, I'm just using this these first 3 columns, and I transpose it. As a reminder, transpose just means to swap the columns and the rows. Take the inverse. If you don't normalize and you have really big numbers, you're going to find you have a singularity in your matrix, and it's going to give you an error, and it's not going to allow you to do it. So make sure that you're using normalized values. And then, so we multiply that first, and then we do this one next, and then we calculate the two of them together. So you're going to find if you're working with Excel, I tend to break it up into like basically this N and the U, and then I do it together. But I end up with my vector for X, so my first order is going to look like this. I need to find what I did with them. There we go. So the first one is 0.5309. The second one is negative 0.0528. And then 0.0299. Now, if these are incorrect, please let me know. Can I denormalize these? No, I cannot, right? So that's first order. My second order. So second, I know this is a disaster on here. My second order comes out to be 0.0, whoops, I keep pressing my button on my pen. 0.0668, negative 0.0, or no, not 0, 373, 1.108, 1.163, negative 1.808, and 0.381. So there's my second order. So I'm going to give you guys a new version of this. But these are my coefficients. So now really, so we've calculated the coefficients. Now we need to put it into our trend, right? So I'm often going to ask you, what was the trend? What was the global model? Tell me the model. Just giving me these values is not giving me the model. So let's get a new one here. And I'm going to just paste in my modeling. And then that. And so let's look at my models. So my Z normalized for first order is equal to 0.5309 plus, or I guess I can say negative because it is a negative, negative 0.0529 xn plus 0.0299 yn. That's my first order. My second order looks like this. So 0.0678 minus 0.333 xn plus 1.1076 yn plus 1.1626 x squared normalized minus 1.8080 xy, and then plus 0.3814 y squared. So this is what I am looking for as an answer. These are your models. They are the trends, they're the models. You can use this to calculate any point. So the thing is, though, is that everything is normalized. So if you want to do anything with this model, your points have to be normalized in order to be able to put them into this. So If I'm going to calculate through though, so I'm going to like just finish up those steps and then I'm going to talk about how that works. So now we need to figure out what L hat is, which is our A x hat. So to calculate that through, we just take our A matrix, we multiply it by our coefficient, and we end up with our new values of L. And so we end up with L hat, so it's for the first order. It's going to be all 15 observations, and we have 0.484, 0.522, dot, 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 all the way down to 0.547. With poor rounding. I didn't round, I just took the numbers as is. So, so make sure you round. I think this one's an 8 instead. So my second order looks very different. So it's all 15 points, so 0.705, 0.506, some of them are close, all the way down to the bottom, which is 0.803. That's the second order. So these are normalized values. Now we want to denormalize them. So to denormalize them, we use the same formula we used for normalizing, except now we're trying to isolate for the Z value. So I guess we can go Z. So this time we take our Z normalized and we multiply it by the Z max minus Z min, and we add Z min. And that's going to denormalize it for me. So then now my L hat regular, because this is all normalized, right? These are normalized. So my regular L hat, so say for the first order, is now 44.3, 47.4, dot, 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 all the way down to 49.6. There we go. So that's first order. Second order is equal to 62.8. No, I'm kind of cramming it in here. 46.1, dot, 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 all the way down to 71.0. Okay, so now if we compare these values to these ones, they look very, very different, don't they? They are in the exact same order, but they are very different. So I have a feeling that my two models, these models do not really match these heights very well. And that's okay, because my goal was to just try to get together a model. So now that I have my denormalized values, I can calculate my residuals. So my residuals is equal to L minus Z. So my original values here, so L hat minus Z, or I think in my PowerPoints I do it opposite. So I have L minus L hat. I'm okay with either way, whatever you choose to do. So my residuals are really, really big in this case. So my first order is like negative 43.32. My next one is 0.51, so that sounds not so bad. Negative 36.417, all the way down. Okay. My second order is also quite large. I have 24.8, 0.82, 32.6, all the way down. Okay, so there's my residuals. So I have my residuals. I have my new values. So these are the values that are on the actual trend. Okay, so I haven't like shifted anything. Just saying, okay, here's my model. These are the values on the model at these particular X and Y points. Now this Z value was my observed. This is my modeled values. These are my residuals from the observed to the modeled values. You can't do that with the normalized values, obviously, because they'd be huge, right? And especially if I have thousands, like if Z becomes in the thousands, you're going to have some huge errors, and you don't want that. So that is, that's getting to that point of error. So of course, like our formulas are plus residuals, right? So then that creates this next part. So now this takes you to the end of really dealing with these matrices. We're done with the matrices. Now what we really want to do is say, hey, what happens if I have a point at 50, 50? What's its height? Well, we go over here and nothing is exactly at 50, 50. So if my point, and I want to say, okay, what is my estimated point because I'm using a model? What is the height of this? So my first step is to normalize, right? Because my global models are all with normalized values. So once I put my normalized values in, I just realized I had an error in my calculation here. So I need to, so the first thing, I'm going to bring this over because this is going to show you guys what I'm doing over here. So I have 50, and so here I need to find out where my minimum value is. So my minimum, I've already done that over here. So that should be my 24. And then I need my maximum value, which is located at 1. So that would be 20. And change that to 24. Right? Then I do the same thing for my y. So that should be in 24 and 20. And then this is for my y. 37, yes. And then let's see 37, so that's good. So now my y value for my minimum is at 27. And my maximum is at 28. And there we go. So that's better. All right. So now we've got those values. So my normalized values for P here is at, so my X value was at negative. Shouldn't be a negative. 37, 24. Oh. I didn't change that. Okay, there. Some errors happening here. Now I'm worried that I've done something that I shouldn't have done. So my X needs to, so, oh, I overwrote my X and my Y. Yeah, that's what I did. So there's my Y. No. Yeah, I totally overwrote it. When you're doing a demo on video, you're like, oh, I'm not really paying attention to what I'm doing. Okay, so my minimum is at 34. And my maximum is at 31 and 34. Make sure that makes sense. So 50, yes, that does. So then we move to, oops. Then we move here, which should also be close to the middle, which seems to be right. So here, yes. So that one is correct. Okay, so you have to use the data set that you're given because that's where we start. Now I can actually write this correctly. So we go 0.508. That's my X, and then 0.525, which is my Y. Now I can use both the X and the Y to calculate it. So my p-value, if I insert everything into here, so at first order, my Z value is equal to the 0.5309 minus 0.0529, put that into the X, which is 0.508, and then plus 0.0299 and multiply that by the Y. Please keep more decimals in your trend than what I have here. Keep them all. Whatever you can view in the software that or the calculator that you have, put them all there. Do not round, because that's going to make sure that you keep this it's more accurate that way. And keep even the p-values, right? So all the way to however many decimals you have. So that's the first order. So we end up with my Z normalized for p. It equals to 0.519. Actually, it's like 520 when you actually round it properly. I would do the exact same with the Zn for the second order. So this is first. So for my second order, my Zn value is going to be 0.382. So you'll see that it's kind of shifted a little bit from that original, that's about the halfway point, right, from that normalized value. So then we have to denormalize for p. So the second step after this, so this is step 1, this is step 2, which is calculating it through. Step 3 is denormalize. And when I denormalize it, my first order comes out to be 69.82, and my second order comes out to 72.5. Should only use one decimal place because it's all is given. And those are my answers for P. So you can see that there is a lot of difference between the two models. Which one is more correct? Well, in order to do that, we have to calculate the statistics of it, right? So I'm going to change my color again. I'm going to actually wipe this off, clear it off, and we're going to do the statistics of it. So our statistics, when we run stats, they are going to be in, we have to do the r-squared value first. So my first value that I need to calculate, which is my trend, SST trend. So this one is when we take the sum of the Z observed minus the Z mean squared. And then we have SSR, which is equal to the sum of the modeled value minus Z mean squared. And then we have SSD, which is my residuals, and we have ZI minus Z hat I squared. So for both models, SST is not going to change because this doesn't matter how that changes. So we have D. Yeah, okay. So I just wanted to double check to make sure because I seem to be doing a lot of mistakes in my prep work of this class today. So 8806.857 is my SST. My average of my SSR is 1593.25, and my SSD is 7213.6. Then we can calculate our R squared. So, oops, that should be a capital R. So this is my goodness of fit. So this value, this value here is for my second order. I did the second order first, and then, so this is second. So my first order, put it over here, it's 32.60, and it is 8774.25. So my R squared value is when I calculate the SSR over SST. So it's how well does my trend fit my actual observations. So for my, let's do first order here. My first order, my SSR is 32.6. Divide that by 8806. And I end up with a really tiny number of 0.0037, which if I put that in a percent, I'm going to multiply that by 100, I still get 0.4%, which is not very high. So my second order, doing the same thing, I have 1593 divide by 8807, and that gives me a value of 0.181. So I change that into a percentage, it's 18%, which again is not very high. So these two models, maybe a third order might actually improve it, because this is actually a pretty big jump in goodness of fit. So third order might be a better option for this particular data set. But I'm just taking you through, what does it look like when you have these numbers. And these were just randomly generated numbers, so that's why it's so low. So then we have to figure out, okay, that's my goodness of fit. So what about my Fstat? So my Fstat, I have to worry about my MSR. And I have my MSD. So I'm going to calculate my MSR. My MSR is this value. So let's start with the first order. So we have 32.60 divided by the number of coefficients minus 1. So we get 32.60, and we had 3 coefficients, so divide by 2. And that gives me my MSR value of 16.30. So my MSD value is now looking at my residuals. So I'm going to just be SSD over n minus m. So write that out, over n minus m. So my SSD is 8774 divided by, I had 15 minus, I had 3 coefficients for my first order. So then that gives me an answer of 731.19. So for my first order, let's finish this up. I have Fstat, and my F statistic equals my MSR over MSD. And that equals 0.0223. So this is first order. My second order, following along with that, my MSR is equal to SSR, so 1593, divided by the M minus N, or 1. And I get an MSR value of 318.6. Then I have to figure out my MSD value for my second order. So my MSD value is the 7213 divided by my N minus M. So this time this is different because we have 15 minus, we had 6 coefficients, so now it's going to be 6, so it's going to be 9 on the bottom rather than 12. So in this case, we get an MSD value of 801.5. So my F statistic, when I calculate that, I have my MSR over MSD. So that is my 318 divided by 801. And that gives me a value of 0.398. So these are really low F statistics. So one thing that you can do, I'm just going to pull over this. What you can do is if you go to Google, and I can look up F statistic critical value calculator. So here's a critical value calculator. So it says the significance level, let's say we want 5%. Numerator degrees of freedom. So this is going, let's go back to what we were working on here. So the numerator degrees of freedom is m minus 1. So if we go back to here, my m minus 1, so for my first order, I had 3, so it would be 2. And then my denominator, going back to the paint again, my denominator is my SSD, so that one is 12. Let's put in 12. And it is a right-tailed test, because it's not two-tailed. Calculate. Oh, sorry, it's left-tailed. No, that's right, actually. So my significance level is 3.885. Okay, so go back to paint. I have like a little glove that I just took off my hand, so I'm just going to put that back on for my tablet. So my Fstat, sorry, not my Fstat, my critical F value. So my critical F value, going back there, was 3.885. Now both of the Fstats are less than 3.885, which means that H null holds true. There is no significance between the two data sets. No significance. So that means that these models would not hold up in court, right? So it'd be like, no, look at the values, look at the F statistic. So I'd need to find another global model to work with. So if I wanted to do the second order, I can change that again. So my significance level at 5%, my numerator degrees of freedom. So I had 5 because there's 6 coefficients. And then my numerator would be 9 because it's 15 minus 6. And it's right-tailed test. Calculate. Take a second as it thinks. And we get 3.48. So that's still a little bit less. This is still much lower than that. So that is, that's how Fstatistic works. Obviously, like, I just made up these numbers. Well, actually, Excel made up these numbers. So I wasn't like true actual values of going out and doing a survey or something. But that gives you an idea as to how to follow through with this whole process. So the idea behind modeling is so that we can figure out what the value or the elevation is of an unknown point throughout my entire area. And at that single point, how reliable is that data? So here we know that both first and second orders are not reliable in terms of what we need for our for determining an elevation value within 5%. I could try going to 25% and seeing if that helps. So I could say, oh, it's within a different significance level. Like here, if I wanted to go 25, how does that change it? If it's a right-tailed test, calculate, see if that makes it bigger or smaller, and see if it makes a difference. I don't think it will, because I think even our R-squared value was really poor for results. So it says it went down. So here's the 1.61, and that's at a 25% alpha. So so again, like looking at that, you're going to say, okay, well, it's still below that at 25%. So you could play around with these types of calculators and say, hey, you know, at what significance level is this? Because then now it can say, okay, within, you know, if this fell within 50%, it's like I'm 50% confident that this will actually match the elevation that we're at, right? So that's another way you can look at these. So I'm using MathCracker. I'll pull that down in here. to do that critical value. But if the value that I calculate exceeds the critical value, then we know that there is a significance, like that it's significantly matching. It does a really good job of matching it. So just as a conclusion, verbal conclusion here, so we went through how to do a global model, how to calculate it. We talked about how to normalize and the full order. So you have to normalize, then you set up your matrices, then you calculate your coefficients, then you write out your trend, right? Make sure you write it out so you actually have the full equation. And then you calculate the trend heights at those particular locations that you already have, the observed locations. So what are the trend heights? Then you can figure out the residuals. And then once you've figured out the residuals, then you can move into calculating your R-squared value and your F statistics. So it's kind of a 7-step process. I've done both first and second order all the way through, so I'm hoping that that didn't confuse too many people with me doing 2 at the same time. And so I was using Excel for all of this. And so just to give you an idea of my Excel sheets and what they look like, so that I have all of this. So here's my values. I've created my normalized values here. Then I have all of my A matrices. So this is, I calculated them up here. So my x squared and xy and y squared. So I've calculated them there. And so I've set up my A matrix, and then I also set up my A transpose, which is here. Then I calculate my ATA, and then I calculate the inverse of ATA, and then I calculated the AL. So if you're looking for the formulas of these, so I took these values, these are all like face value. You can see that I've done like the math here of multiplying the two together and everything. This is my second order. Then down here to transpose it, I transpose. And then to calculate, it's M mult is the calculation. Then to do an inverse, it's min inverse to do the inverse. And then again, multiplying there to get ATL. And then up here, I did my multiplying of my n-1 and u, and to get those values. Now with this, I was able to do first and second order all at the same time because I could just take fractions of my value, or like of my A matrix and my L matrix. So here's my first order as well. So you can see that I have my transpose. So I only took the first part, then I took a fraction of that to calculate ATA, and then I use those values to do the inverse for ATA inverse. And then I use the M multiplier to get that. And then I get my answers up here. So you can see my multiplying there. So there's the answers to that. Then I calculated through, I multiplied my A matrix with my coefficients. And I did that for both first and second order. And then I calculated, I denormalized all of my Z values in this, in this column, these columns for both first and second order. And then over here I have my first and second order R values, so my residuals. Then once I've had those residuals, I moved down into doing my statistics. So I calculated the SST, and I did it with the SSR for both first and second order. Then I did it with the SSD for both first and second order. And then I calculated my R squared value. I just didn't take it into a percentage at this point because I just said R squared. And then I did my MSR values here. And then I have my Fstat. So I know I clicked through those really fast, but the best thing is that you can slow it down on this video and go as slow as you like. So you could like do, hey, 2 seconds, stop there, and then stop there, and then stop there. So if you're looking for the formulas, that you've got the formulas in Excel here, but and of course the way I've set it up is probably not the way that you would set it up. because I have like 10 different questions going on at the same time for this example. As you can see, examples for videos. so it's all together in one. So keep that in mind as you work through this. So that's global modeling. Please slow it down, and if you want to use Excel and you're trying to copy what I'm doing here, you can see where everything's laid out, how I've laid it out. Please change it in a way that makes sense to you, because this is kind of chaos a little bit here. So that's everything for global modeling. I know this is a very long video to go through, but it does cover all the aspects of it. And your next video will be on the local modeling.